No, what was I saying? Um,
The passing grade.
oh, right. Thank you, Cheryl. The passing grade for this course is a C. You really need a C. They are not this term. The last two terms, because of COVID, they allowed you to just barely pass. If you got a D minus even on a course, then you that was considered passing, and you could just take it as a pass for the course, and you were okay. You just because they had this pass fail. Either you passed or you failed if you wanted to take that option. That option, as far as I know, is not going to be available this term. So in order to pass this course, you must get a average of at least 70. 70 is a C, and you have to get a 70 in order to pass the course. Now, if you notice that your average at this point is not up to 70, of course, there's still the final coming, which is 35% of your grade. But you don't want to rely on that only. I don't think it's possible to get a passing grade on this course with just passing the midterm and the final. You must have done classwork. That's part of it is for me to see that you've been participating and working and doing the work, not just taking two tests, and that's the whole thing. So I know I'm not talking, and most of the people here are taking this seriously and are doing the work. And notice not only that, even if your mark on your midterm wasn't as good as you would have liked, if your other work is that can definitely raise your final grade. So um, as you notice, I followed the rules and I tried to work out the grades exactly. Now, towards the end of the term, there are people that have been participating extra or have been doing extra work or have been on time or done. There are certain. So at the end of the term, I do assign to each person according to what they've done extra points. The mark I gave you now was the straight mark, no extra points. So your grade at this point is probably a little bit higher than what I sent you out. But if you see that I sent you a note that you're in danger of failing because you did not complete all the work, that's a strong message. You have 6 weeks, you can do the work. I will give you pretty much full credit for anything you do, even if it's late. So if you, and a couple of people did ask me to reset quizzes and Delta Math or the test on Blackboard. And if you send me, I will reset it so you can start it from fresh. Even if you got a bad mark on it and you didn't like the mark and you want to redo it, I will reset it for you and you can redo it. Okay.
Um,
Yes.
good morning, bro. This is Jonathan. Good morning.
Hi,
I sent you an
Jonathan.
email recently because I right now currently I don't have access to my the account, the Mega Everest account. So I just emailed you in terms of me trying to receive my average score for the class.
Okay, so just email it to me and I will send you a copy of the email I sent you.
Okay, thank you.
You're doing very well. Okay. So I want to go on with solving of ra- rational equations, specifically those type that do not have that are not proportions. For example, suppose I gave you a question that looks like this. Y over 2 plus let me, I really actually want to do one that's a little bit simpler. 5 over 2x equals 2 over x minus 1 over 12. What do we do when we have an equation that has a lot of fractions in them? It's not a proportion because even though on the left side there is a single fraction, on the right side there's more than one fraction. And I'm going to show you a method that I think will work out the best for you. And that method involves finding something called the LCD, which we learned already because we know when we want to add fractions, we have to find the LCD, the least common denominator. So let's see if we can figure out what the least common denominator here is. Remember, these are all monomials, single terms. When they're single terms, we look at the letters separately and the numbers separately. When we have polynomials, then we know we have to factor. We're going to do that, another one like that in a minute. But first, let's look at this. So let's first look at the numbers or the coefficients. There's a 2 here, there's a 1 here, and there's a 12 here. What number do all of those numbers go into? What's the common denominator? If I didn't have the x's, if I just had a 2, a 1, and a 12, what would my common denominator be?
1.
No, 1 is what goes into, we're looking, that's a common factor. What we're looking for is the common denominator, the number that they all divide into. What does 2 divide into evenly? What does 1 divide into, and what does 12 divide into? Yes, Emma, you're completely correct. That number would be 12. The common denominator is always as big as or bigger than the smallest denominator. That takes care of the numbers, but we have letters as well. We have an x here and an x here. When it comes to the common denominator of the letters, of the variables, all you have to do is pick the highest exponent. And this has an exponent of 1, and this has an exponent of 1. So obviously x to the 1, or just plain x, is the common letter, the common variable of the common denominator. So my total common denominator, remember I said when it's monomials, I look at the numbers separately, and then I look at the letters separately, put them all together. My common denominator for this is 12x. Now, what we're going to do is now we're going to rename each of the fractions so that they have a denominator of 12x. And if you remember when we did this in addition, what we do is we divide the original denominator into the LCD. So 2x into 12x, the 6, 2 into the 12 gives me 6. The x cancels out. So what I want to do to this 5 is multiply it by 6. 5 times 6 is 30. Let's do the same thing with this fraction. We divide the 1x into the 12x. The x's cancel out. I'm just left with 12. I have to take this 12 and multiply it by 2. That gives me 24. And finally, I do the same thing with the last. The 12 into the 12 cancels out. What it leaves me is x. I have to multiply this x times 1. 1 times x is x, or 1x. So now I found the common denominator. I renamed each of my fractions with the same common denominator. And here's something that you never do when you're just adding fractions, but when you're solving an equation, and you'll know it's a solving because it'll have that equal sign, you can totally ignore the denominators, rewrite the whole equation without any denominators. Just write the tops. 30 equals 24 minus x. Once you have the same common denominator, then the equation just becomes the equation of the numerators. And of course, that's a much simpler equation to solve. If I want to solve this, I'll bring the 24 to the other side. 30 minus 24 is 6. This cancels out, gives me negative x. Be careful with that because there's a negative. I have to divide by -1 to get x equals -6. And that is the solution of my equation. Okay. Now, you may have learned a different way of solving these by multiplying. I had showed you once by multiplying by the common denominator. If you have another, if you have a different way that you know that works and you want to use your method, that's perfectly fine. But this is what we call finding the common denominator and this writing the equation of the numerators. And that method will always work for you, even if it's a proportion. You could use this method if you prefer. Yes.
Teacher, yeah, good morning. Layla, she says she's trying to get back in because she has a problem. She got out by accident.
Well, I don't have control of it now. Melissa?
She's in.
She's in? Okay, there you are. Thank you. Okay, I'm going to give you one of these to try on your own. Okay, can I erase this?
No,
Anybody?
no.
I should leave it?
Please.
Good job.
1 second, please.
Go ahead.
Okay. Are we okay?
Yes, it's okay. Thank you.
Okay. Okay.
Our what? Garden. Let me see garden. Are you looking at the first letter in the word?
It did not hurt.
All right, so you gotta be looking at your screen. You can't read anything if you're not looking at the screen. This is our
1 minus 1.
good job, Alina Diamond. This is our house. I think, is it just Juliana that needs to go? And then I think everyone's good?
Over x squared.
Last night word. Out.
Azia, please, okay.
Sorry, Professor.
Yeah, okay. All right, here, the equation I'm giving you is 1 minus 1 over x equals 12 over x squared. And I'm gonna start you off. First of all, what we didn't have in the other one that we have here is that one of the numbers or things doesn't have a denominator. In other words, they're not all fractions. This is a whole number. But really, when you're working with fractions, it's much better if everything is written as fractions. So remember, any whole number can be put over 1. So, I'm sorry. So rewrite your equation so it's 1 over 1 minus 1 over x equals 12 over x squared. Okay, see if you can figure out what the common denominator is and see if you can solve this equation. While you are doing that, I'm going to be taking attendance. Azia, Nashia,
Yes, Professor.
And I saw,
Nashia Allen, Annabelkis Baez, Emma Benedict,
I am present.
yeah, I did know that because I gave me an answer before. Messiah, Messiah, Corey Brown. Corey?
Here.
Yeah, good morning.
Morning.
April,
Morning, Professor.
good morning. Khadija. Khadija. Umar.
Good morning.
Good morning. Yakima,
Good morning, Professor.
good morning. Cheryl, we've been talking back and forth. Okay, I know you're here. Stacia, I'm pretty sure I saw you come in.
Yeah, I'm here,
Stacia.
Professor. Yeah, I'm here.
Denisha, I know you're here. Devana,
Present.
morning. Natalie,
Good morning.
good morning. Erica,
Good morning, Professor.
morning. Jonathan, I know you're taking care of everybody. Luke. Luke, I saw try getting in earlier. Is Luke here?
Here.
Good. Layla,
Hi, Professor. Yes, I'm here.
good. Ashley. Ashley. Kachira. Kachira here?
Here. Good morning.
Good morning. Jennifer,
Right here.
good. Rachel,
Good morning. I'm here.
good. Gloria, okay. Looks good. Are we ready to try it together? Anybody want more time? Okay, so let's get started. Does anybody want to tell me what they think the LCD is? What is the LCD? You think X is?
X squared.
What? Am I getting it?
Does everybody think it's X? Remember what we said. First of all, there's 1, so that doesn't matter. But here's an X and here's an X squared. What did we say the LCD always was?
Would it be X squared?
Right, it's going to be the X squared. When you're looking for the LCD, you're always looking for the larger thing. When you're looking for the common factor, you're looking for the smallest. But when you're doing with fractions, when you want to get the same common denominator, the LCD is always the larger exponent. So it's going to have to be X squared. So we're going to have to rewrite each of these fractions with X squared on the bottom. So step 1, find the LCD. Remember, it's the bigger thing, not the smaller, it's the bigger. Then the next step is to rewrite each of your fractions with that same common denominator. And we do it by dividing the original denominator, the 1, into the X squared. Well, 1 into X squared just gives you X squared. I'm putting it on this side. And I take that X squared and multiply it by the 1. In other words, it becomes X squared over X squared, which makes sense because X squared over X squared is 1. We want to make sure all the denominators are the same and all the numerators have been changed to get us to the right numerator. Okay, so now we take the second denominator, the X, and divide it into the X squared. And what I get over there is X, because X into X squared is X. So now I multiply the X times the 1, and that gives me 1X, or X. And finally, I divide the X squared into the X squared. That cancels out, leaves me only 1, and 1 times 12, this stays 12. I didn't change the denominator, I don't have to change the numerator. Now that all the fractions have the same denominator, I can rewrite the equation as X squared minus X equals 12. I write the equation without the denominators. The whole point of this is to get rid of the fractions, to have just regular equations. Okay, now I'm going to leave you right here. I'm going to give you a few more minutes to solve this equation. Remember, it's a quadratic equation now because it has an X squared. Okay, give me a couple minutes to try that if you didn't finish it up or if you made a mistake. I see some people already came up with the right answer. Stacia, you want to tell me how you got to your answers?
I can try.
Okay.
Okay, so after I have that, I wrote my X squared minus X
Yeah.
minus 12, and I put it to 0.
Okay, so she realized since it's a quadratic equation, you don't mind if I add some commentary?
No, you could go.
No, she's gonna get it equal to 0. So she got X squared minus x minus 12 equals 0, because it's a quadratic equation. It has x squared. Okay, what
Yeah.
next?
Then I found what two numbers can give me 12, but when I subtract them, it gives me 1. And that will be 3 and 4.
Okay. Perfect.
Yeah, so I have now x squared plus 3x.
Okay, how do you know which one's the positive and which one's a negative?
The bigger one will be the negative, which is the 4.
Because the middle is negative. So it's
Yeah.
plus 3x
Minus 4x minus 12 equals 0.
Okay, I'm just transferring up here.
So now because I have the x squared, I'll go ahead and put the x plus 3.
Okay, so in the
And
first,
then
yeah, in the
go
first
ahead.
year, she factored out the x.
Yeah, and then I have x plus 4.
You have x plus 4.
X minus 4, sorry. X minus 4.
Yeah, you have a minus 4
Yeah,
and the x plus 3.
yes.
Okay, so that gave you the x plus 3 and the
And
x.
then I have x minus 4
Wait,
equals 0. Okay, so now I go ahead and I write them separately, which I have x plus 3 equals 0, and I have x minus 4 equals 0. So when I brought the 3x over to the 0, it becomes negative. So I have negative 3x, negative 3, sorry. And when I brought over the 4, it becomes positive.
And there, how she got her two answers, negative 3 and 4. It looked very similar to the last one, but this one ended up with two answers because we ended up with an x squared. So it's a quadratic equation. So sometimes you end up with a quadratic equation. Sometimes you end up with a linear equation. I want to do one more example. Can I erase this or do you want me to leave it
No,
on?
give me 1 second, 1 second.
Sure. We're going to look at what happens if my denominator is not a monomial, but what happens if I have a polynomial denominator? I'm going to do one and then I'm going to give you one to try. And then I think we will have accomplished what we want on this chapter, which is working with fractions. It's quite a difficult chapter because fractions in general are difficult. And what happens is, even if you get rid of the fractions, you still have regular equations to deal with, and you have to know how to deal with that. If you've noticed, our course has gone, each step sort of builds on what we learned before. So you have to keep current. That's why I keep saying, if you're missing homeworks, don't worry about it, because we're still using the same material. You should not have forgotten what we learned at the beginning of the term. You still need it. Can I erase it?
Yeah, go ahead.
What topic is this? This is called rational equations. This is rational equations. Okay. So let's do one more example. Here's the example I want to do. I have x over x minus 2 plus 2 over 3 equals 2 over x minus 2. And what's different about this is that my denominators are not just single terms. My denominators are polynomials, or some of my denominators are polynomials. But the method that we use of finding the LCD and then renaming the fractions is the same method. So when I have polynomials, the first thing I want to do is make sure all my denominators are completely factored. And I happen to be lucky because x minus 2 is as simple as you get, and 3 is as simple as you can get. So you don't have any factoring to do. If you recall what we did when we had to find our common denominator, when we had polynomials, this is going back to adding fractions, adding or subtracting fractions. The first thing after we factored, we then took a pen or whatever, or in our mind, circled all the different factors. Now, in the first fraction, I have an x minus 2. I always circle everything in my first fraction. Then I go to my second fraction. That's 3. I don't have the 3 circled yet, so I circle that. Then I go, even though it's on the other side, it doesn't matter. When it comes to an equation, I do everything. I have an x minus 2. I've already circled the x minus 2, so I don't have to circle it again. And if I look at all the things that I circled, which was the x minus 2 and the 3, and I'm going to put the 3, usually you put the single number first, but if you would have wanted to write x minus 2 first and 3 second, those are the two things that we circled. That is my common denominator. I am going to now rewrite. Oh, I'm sorry. Why am I writing this as plus? It's a minus. Each of these fractions with this common denominator of 3 and x minus 2. And if you remember, when it comes to the polynomials, it's really sort of easy because all you have to do is compare. I'm dividing the x minus 2 into the 3 times x minus 2. The x minus 2 is canceling out. Remember, that's what I checked. So what I'm left with is the 3. I have to multiply. I already had the x minus 2. The new thing I had was the 3. I take that 3 and multiply it by the numerator. 3 times x gives me 3x. Over here, I already had the 3. So what I have to multiply this by is 2. So this is 2 times x minus 2. Now, if you wanted to, you could actually multiply it out, or you could just do like I did, put it in parentheses. The new thing was x minus 2. That's what I have to, I compare. The 3 is here. X minus 2 is new. That's what my 2 on top is being multiplied by. And now I go to the last thing. The x minus 2 is here. So what I have new here is the 3. I have to take that 3 and multiply it by the 2, which will give me 6. Notice when it's really easy multiplications, like here I had to multiply 3 times x, I don't have to put it in. This is a little bit more complicated, so I wrote it out, though you could have just multiplied it. You then, now that we have everything over the same common denominator, can ignore the denominators and just write the equation. 3x plus 2 times x minus 2 equals 6. I have made the equation much simpler because once they have the same denominators, I really only have to work with the numerators. Remember, if this was just an adding of fractions, you couldn't get rid of the denominators. You work with the numerators, but you have to keep putting in the denominators. But when it's an equation that to solve, you don't even have to write in those denominators anymore. But you have to solve this equation. So we do 3x. Now I'm removing the parentheses. This is a regular equation now. It's 2x minus 4. Don't forget we're using the distributive property equals 6. So adding the like terms, this gives me 5x minus 4 equals 6. So that gives me 5x. I bring the 4 to the other side, so it gives me 10. And if I divide everything by, once I have 5x equaling 10, I can find out what x is by dividing both sides by 5, and it gives me x equals 2. And I've done everything correct. Again, the hard part is, number one, figuring out what the common denominator is, though it's not so hard when it's polynomials. You just take all the different things and rewriting the fractions. Once they're rewritten, you can totally ignore the denominator and just write your equation of the numerators. Now, I want to show you something interesting that happens here.
Oye,
I'm going to check this equation.
se me sale en el cuarto, llamaba a cliente, va a coger nosotros para mí para
Jennifer, please.
arreglar el carro.
Eso no son mis problemas. Yo lo que sé que yo le mandé su cuarto, ya yo le pagué, eso no tiene nada que ver conmigo.
Pero yo te lo voy a decir,
Can you move?
Es que no, tú no.
Okay, thank you. I think people don't realize it sometimes. I'm going to check. The answer I got was x equals 2. So checking, I go 2 over 2 minus 2 plus 2 over 3 equals 2 over 2 minus 2. Now let's see what happens. This gives me the 2 on top. 2 minus 2 is 0, plus 2 over 3 equals 2 over 0. And something very strange has happened. When I went to check, my denominator ended up equaling to 0. It happened to be on 2 denominators, but I didn't even have to go any further than the first denominator. I know that we're never allowed to have a fraction with a denominator of 0 because you cannot divide by 0. 0 is the one number you can't divide by. You can't do 2 divided by 0. If that happens, the answer we get, x equals 2, is what we call, is an answer that we are not allowed to use. We have to actually throw out the answer. We can't use an answer that tells us to do something that's not allowed. You're not allowed to divide by 0. 2 cannot be the answer. Sometimes the term used is extraneous root. The word extraneous means something, it's an English word. An extraneous root, or anything that's extraneous, is something extra that pops up that came out as a perfectly good set of work that we did, but really is not allowed. This is an extraneous root, something extra that we don't want. So in this case, we have to throw out this answer. This answer is no good. And therefore, there was no solution to this equation. Here, all that work, it looked like we got the right answer, and that answer didn't work. But we had to do all this work to find out the answer, but what we have to do is also check the work. So what does this mean for us? When we have rational equations, equations with fractions, when you get to your final answer, even if you don't have time to check everything, check your denominators. If I would have seen right away when I got x equals 2, I would have seen right away 2 minus 2 and made a denominator is 0, I would have known it can't be an answer. So if you don't have time to do a complete, you must check your denominators to see that they're not equaling to 0 when you substitute your answer.
Professor,
Yes.
I have to leave right now. I know it's like a few minutes before class end, but I have to leave. I'm like going outside
Okay.
and I won't have connection.
Okay, no problem.
Thank you.
Okay, so now let me give you one more question. Let's do one more. I'm going to give you one to try, and let's see if you can come up. Can I erase this now? Anybody need me to leave it on? Okay, so let's erase it, and I'm going to give you one to try, and then I would like to start with one other topic. So let's look at this equation. See if you could solve this. 8x over x minus 8 minus 4 over x equals 32 over x squared minus 8x. Okay, so what I first want you to do, I want everybody to figure out what is the LCD. I do have myself pinned. You have to pin me. Natalie?
Miss Pearl, did you take attendance yet? It's Messiah.
You know what happens? When it comes to pinning, I pin myself. I am pinned, but you have to.
Try pinning you, but it's not working for me.
But if everybody else, and truthfully, it's not, you're going to the corner and it's not working.
Yeah, because I always pin you.
I don't know why that shouldn't be. I don't know why you're having that problem. Because I have myself pinned. Melissa, is there anything you could do? Does that have anything to do with you?
I didn't touch anything, so I don't know.
You know what? I would try, Natalie, try going to,
I got it to work.
oh, okay.
Thank you.
You're welcome. Nothing of my doing. Thank you. Usually when I'm talking, anyhow, I'm pinned, but there was a lot, I don't know why there was extra. Okay.
Miss Pearl,
Yes,
it's Messiah. Did you take attendance yet?
I certainly did, but I will check.
Oh,
I see you're now here.
yeah, I've been here for a while.
Oh, okay.
Okay, thank you.
I'm doing that right now. I'm just going to check anyway to see if anybody came. And sometimes people's things don't work. Okay. does anybody want to tell me what they think the common denominator is? Okay.
Would
Remember,
it be x squared minus 8?
minus 8x.
Yeah, okay, I didn't see the x. Sorry about that.
Right. If you notice, when and I would do it in the factored form. Remember, when we want to find a common denominator, we have to factor all the denominators. And this can't be factored. It's simple as possible. This can't be factored. But this factors, it has a common factor of x. It becomes x and x minus 8. And if you remember what else we did is we went and we circled all the different factors we saw. So the first thing we see is an x minus 8. Then we have an x. Even though the x is part of it, when it's a binomial, you can only use the whole thing. So this is really something entirely different. So I circle the x as well. But then if you notice, I already have the x circled, and I already have the x minus 8 circled. So therefore, my common denominator, my LCD, is x and x minus 8. So we're going to have to rewrite these fractions with that common denominator of x and x minus 8. Okay, so let's compare. In my first fraction, I have an x minus 8. So what I don't have is the x. I have to take this 8x, I'm just going to write it, and multiply it by the x. Now, you could have written it as 8x squared if you want, but I'll do that at the end. Over here, I have the x. So what I need to multiply by is x minus 8. So this is going to be a 4 and an x minus 8. Notice all I'm doing is I'm comparing the original denominator with the new and just sticking the thing that wasn't there before in the top. The x minus 8 wasn't there before, so I stick it in the top. Over here, I have both the x and the x minus 8. I don't have to do anything. I can just leave it as 32. Notice once you found your common denominator, then you have to rewrite it. It's not so hard when it's polynomials. So if I look,
Professor, why do we leave the 32 the same?
look at the original denominator. It was an x and an x minus 8. That's exactly what my common denominator is. Did I change my common denominator? Did I change the common denominator?
No.
If I didn't change the denominator, I don't have to change the numerator.
Oh, okay.
Okay? So now look what we have. We have 8x times x. Now they're all in the same denominator, so I can just write the equation without any denominators. And 4 times x minus 8 equals 32. I have made the equation much simpler. There's no denominators. It complicates everything and makes it look so confusing. So once you have the same denominator for everything, just rewrite your equation without that denominator. Well, of course, now we have to simplify and write the equation. 8x times x is 8x squared. Negative 4 times x is negative 4x. Negative 4 times negative 8 is plus 32. And that equals 32. You have to be very careful. Remember, this negative applies to everything being multiplied. This is a negative 4 that times the x minus 8. That's why this became a positive 32. And this is obviously a quadratic equation because it has an x squared in it. So I want to get it equal to 0, so I'm going to subtract 32 from both sides. So that'll give me 8x squared minus 4x, and this cancels out, and this cancels out, equal to 0. And I see what I have is a common denominator, a common factor. I'm sorry. This can be factored, but it's got a common factor of 4x. So this will become 4x times 2x minus 1 equals 0. And going over here, then I'll separate it. I'll get 4x equals 0 for one answer will give me one answer, and 2x minus 1 equals 0 will get me the other answer. Remember to always check if you can factor a common factor out. Now here, if I divide both sides by 4, it gives me x equal to 0. And here I get 2x minus 1 equals 0. I'll add 1 to both sides. That'll give me 2x equals 1. So my other answer is a half. I got two answers, 0 and a half. But remember, I have to check to see there are no extraneous roots. So first checking with x equal to 0. My first equation becomes 8 times 0 over 0 minus 8 minus 4 over 0. Oh, I can stop right here. I don't have to go even further. This has a denominator of 0. X equals 0 is an extraneous root. It cannot be used. Notice I don't have to do a full check. I just want to see that my denominator is not equal to 0. What about when x equals a half? So I get 8 times a half over 1/2 minus 8 minus 4 over a half equals 32 over a half times a half minus 8. And none of these are really complicated, but all I'm looking for, is there any zeros over there? There's no zeros. So this answer probably, I did all the right work. I'm assuming I did it right. X equals a half is my answer. Notice it turned out to have only one answer because the other answer was an extraneous root and could not be accepted. So this was a relatively hard, a really hard problem. Again, the important thing is at the end, check to see if you don't have any extraneous roots. This is about as hard as an example as you could get. Does anybody have any questions about this? Okay. All right, so I want to, we have about half an hour left, so I want to do, there's one more topic left in this chapter that we didn't cover yet. I don't think we're going to get through the whole thing, but we certainly will be finished by Thursday on chapter 5, and we'll be beginning chapter 6 on Thursday. Don't forget to check your Delta math to see if there's any new assignments. Again, I will be letting you know when there's a quiz on Delta math. After we finish chapter 5, I will be giving you a quiz on Delta math on chapter 5. Can I erase this? Anybody still need to copy? Okay. if you recall, when we started chapter 4, chapter 4 was a chapter on polynomials, and we learned how to add, subtract, multiply, and factor polynomials. And the one operation that we didn't learn, or we sort of skimmed over, was the operation of division of polynomials. And I'd like to just, and that happens to be part of chapter 5. So I want to talk about how do we divide polynomials? And I'm going to do it in 2 sections. I'm first going to start with division of a polynomial by a monomial. And then I'm going to do a division of a polynomial by a polynomial. So let's say I gave you an example like this. 10x to the 5th minus 15x to the 4th plus 20x to the 3rd divide by 5x squared. This is an example of a polynomial divided by a monomial. And what we do when it says divide, and it's not a question of factoring. It says when the operation says divide, what they want you to do is to take each term in your polynomial and divide it by the monomial. The easiest way to do that is just to separate. Take each term, the 10x to the 5th, and put it over the 5x squared minus the 15x to the 4th over the 5x squared plus the 20x to the 3rd over the 5x squared. In other words, change this to an example in which you're taking each term from the top and putting it over the denominator. You're separating it. Remember, when you're adding, you really put things together. Here we're separating it. We're putting each term separately over the denominator. Now, what we have to do then is simplify each fraction, and we know how to do that. Remember, when we're dealing with monomials, let's see, when it's monomials, you just take the coefficients, the numbers, and reduce them. Then you take the letters and you reduce them. Now, between the 10 and the 5, I can cancel out the 5. 10 divided by 5 will give us 2. And you have to be careful to do about this neatly. Then when you have an x5 and an x squared, remember you always cancel out the one with the lower exponent, which in this case is the x squared. And you divide the higher exponent minus the lower. 5 minus 2 is 3. So this gives you x to the 3rd on top, because that's where the higher exponent is. Notice on the bottom, everything canceled out, so that leaves me 1. So this becomes 2x cubed over 1, which is just 2x to the 3rd. Then you do the same thing to the next fraction. 15 and 5, you can cancel out the 5. On top, it'll leave you a 3. The x fourth and the x squared, the lower exponent is the x squared. Remember, that means this is a 1. 4 minus 2 is 2. So my next thing is negative 3x squared over 1. I remember the 1 in the denominator does not have to be put in. And finally, the 5 and the 20, the 5 cancels into the 20, gives you 4. The x squared again is the lower exponent. 3 minus 2 is 1, so that it becomes x to the 1 or 4x. And here, again, your denominator is 1, so you don't have to put it in. Your final answer becomes 2x to the third minus 3x squared plus 4x. So basically, you change this with however many terms you have in the numerator, you end up with doing that many little divisions. Again, because it can get messy. So make sure you leave yourself enough room on your paper so that it doesn't get so crowded that you can't see what you're doing. Okay, here's one for you to try. This actually happens to be number 13 on the example sheet that I gave you. Okay, we have 15 a third b plus 30 a squared b squared plus 20 a b to the third divide by 15 a third b. And I'm going to give you a few minutes to try that on your own. Okay, I see that there are some answers here, so let's see if we can actually do this. I'm erasing this one. Okay, like we did before, we're going to take each term from the numerator and put it over the denominator. So it's going to be 15 a third b over 15 a third b plus 30 a squared b squared over 15 a b a third b plus 20 AB third over 15 A third B. I think this is almost the hardest part, is making sure you copy things correctly, because there's so much going on here. Okay, so now we're dealing with the first fraction. First of all, the 15s both cancel out. Then we have an A third and an A third. They're both going to cancel out. And then we have a B and a B, and they're both going to cancel out. In other words, the numerator was identical to the denominator. Everything canceled out. Be careful. That means that you're left with a 1. This is a 1 over 1 or a 1. When everything totally cancels out, don't just drop it. This is canceling out or canceling out by division. So when you divide something by itself, you're left with 1. Okay, so our first fraction is 1. Now we go to the second one. There's a 30 on top and a 15 on the bottom. We can cancel out the 15. 15 into 30 gives me 2. Then there's an A squared and an A third. The lower exponent is the A squared, so that gets canceled out. The 3 minus 2 is 1. I get A to the 1, or just plain A, on the bottom. Because the higher exponent was on the bottom. Then we go to the B's. There's a B squared and a B. The lower exponent is B to the 1, or just plain B. 2 minus 1 is 1, so that gives me B to the 1, or B. On the top, because the higher exponent on that one, on the B's, was on top. So that fraction becomes 2B in the numerator over A in the denominator. Now, you have to be careful, because it can get really messy. Leave yourself enough space on your paper so you can see what's going on. And don't scribble it so over that you can't see what's underneath. Okay, now we have a 20 and a 15. What goes into both 20 and 15? Obviously, that's 5. So 20 divided by 5 is 4. 15 divided by 5 is 3. Then we get to the A's. On the top, we have an A, which is an A to the 1. On the bottom, we have an A to the third. So the lower exponent is a plain A. 3 minus 1 is 2. So I'm left with an A squared on the bottom, where the higher exponent is. Then there's a B third and a B. So the lower exponent on the B's is on the bottom. That gets canceled out. And 3 minus 1 is 2. I get a B squared on the top. So the last fraction becomes plus 4B squared over 3A squared. And that would be your answer. I know it's an interesting answer, but that's when they say divide, that is what they want you to do. They want you to end up with a bunch of separate, simplified fractions. Does anybody have any questions about this? I see some people did not get this answer. Be careful with where you put your letters. For example, over here, the A is in the bottom and the B is on the top. Over here, your B squared is on the top, your A squared is on the bottom. Be very careful. You always cross out the one with the lower exponent, and you're left with it in the higher exponent. Also, if everything totally cancels out, you must put a 1 there, because something divided by itself is always 1. It's not nothing. It's not subtraction we're doing here, it's division. Any questions about some of those answers that weren't correct? Okay. So I just want to get started. You know what, we only have 10 minutes left. I think it doesn't make sense to start a new topic. We'll start that new topic of division of a polynomial by a binomial. What happens if we have more than one term in the denominator? How do we go about doing that division? We're going to see that what you really have to know is how to do long division. Now, if you forgot how to do long division in elementary school, just brush up on it so that you'll remember the steps when we start doing this in class on Thursday. Also be on the lookout for a new, there was an assignment that's due. I think I extended the due date on the new assignment in Delta Math to April 8th, but I'm definitely going to put an additional assignment, and I'll let you know when there's going to be a quiz on Delta Math available for you. Again, please check if you didn't see the email that I sent you with your present grade. Please check for it. I sent it from Blackboard, so it's on the email address that you gave into Blackboard. If you didn't get it, just email me and I will send you a copy of what I sent you on that email. I can send it, just email me to my email address. If you have any questions that you want to ask me, just either come on class. I am always available before class starts, certainly by 9:30.
What's wrong with that? Why are you playing with it?
Ivana. So if anybody has any questions, and you want to ask me in person, just let me know that you want to meet with me and give me a time you want to meet with me, and I can certainly meet with you anytime you want on Zoom, or we can just deal with it through emails, whatever works for you. But please, now is the time. If you're, a lot of people are doing very well, and I can't be more thrilled than I am. But for those of you who are not doing as well as you or I would like, now's the time to pick up your work and make sure you get the grade that you want to get for this course. All right. Melissa, are you having session now?
Yeah.
Okay, so I'm going to leave now, and I'm going to leave you to you unless anybody has a particular question that they wanted to ask me.